In our last video, we were introduced to the normal distribution and a number of the special characteristics that it has. We learned to solve for the area under sections of the normal distribution curve using a table of z-scores that correlates to probabilities or areas under that curve. Today, what I want to do is introduce you to an alternative way using electronic means, or specifically using Google Sheets to solve some of these things for us as well. Today we'll compare and contrast the two methods. Before we begin, I just want to set us up for the three types of scenarios that we're going to see in finding the area under the curve of a distribution. Our first scenario will be for a given value along the x-axis, we'll call it A, and it could be ahead of or behind here the mu value. It doesn't matter, I just chose there as an arbitrary place. If I wanted to find the area under that curve, or the probability of having that value of xn less, I can communicate it one of two ways, either with the less sign only or less than or equal to, it doesn't matter. In Google Sheets, what you would do is you would obviously have your spreadsheet and you have your columns A, B, C, D, and so on, along with your numbers 1, 2, 3, and so on. And it doesn't matter where in the spreadsheet you pick a cell, you can pick it anywhere and input this programming into it. So, I mean, you could even choose cell A1. And what you would type in if you wanted to find the area of the curve is you would type in equals norm dist. And Google Sheets doesn't care if this is in capitals or littles, so I've chosen to put it in littles. It also has an alternative way of doing it, of putting a dot between norm and dist, but it doesn't make a difference which may you use. So I figure, why press an extra button if you don't have to? So norm dist, and then in brackets, and you'll have to put up the bracket, you'll put the value of A, you'll put the value of the mean, the value of the standard deviation for this curve, and then the word true. And again, the word true doesn't have to be in capitals, it can be in littles, and then finally conclude with the other bracket. And then when you hit enter, after you've punched all of that into your cell, you should end up with the value of an answer as a decimal, not as a percentage. Okay? The next scenario that we can explore is finding the area of the curve for a given value of x and above. And again, we can communicate it either way using greater than or greater than equal to sign, doesn't matter. And because our tables give us probabilities from an x value and under, if we want to go here and above, we have to do the whole curve and subtract the pink section in order to get the green section. Okay. However, programming that into Google Sheets, you can do it as 1 minus, and you can put in the same information up above here, here as well. So it'll do this minus, this is essentially the pink, to give you the green. Okay, so one minor change in the programming in the cell of the spreadsheet. A third scenario that we will run into is trying to find the area under the curve for a section that has straight lines on both the left side and the right side. So I've denoted those sections as orange A and purple B, representing two different values of x, and we want to know the probability within that range. So again, what we need to do fundamentally is find the area under the curve from B onward and subtract off A onward, and that will leave us with the strip in the middle. Okay, so that can be communicated as the probability between A and B, either with or without that equal sign. And as I just said, we will program equals normal distribution, put the B value in so that you're finding the area of this curve with its mean and with a standard deviation for the curve, with the word true at the end, finish the bracket, subtract, same thing, area of the curve for the A. Okay, so this is all at the top of your note, and we will practice using it in today's examples. So I would ideally like to leave this up, but I need the space for the examples that we're going to do. So fortunately, you have it at the top of your note, and you can refer to it as we go along. And I would invite you to pause the video for a moment to actually open up Google Sheets beside you on either a phone or whatever device you have, so that you can actually practice punching it into Google Sheets. I elected not to include the electronic version here just because the logistics and the timeline that I'm working with here aren't going to work as such, but I'll talk you through it. So in example 2 of your note, you are given the following. We know that we can communicate a normal distribution in a very short form way that looks like this. We learned that in the last lesson. We learned that n means normally distributed. This first value here is the mean, and this is the variance, or standard deviation squared. So therefore, our standard deviation has to be the square root of 25 or equal to 5. And this is a step I like to do even before reading the rest of the question. So first thing we're going to do is we're going to find the probability under that curve for when x is less than or equal to 45. Now, what I like to do in these questions is I like to incorporate both the mathematics with a visual as well. So I'm going to do a quick little sketch of this scenario. And in fact, I'm going to put the sketch up here because I'm just going to erase it and apply it to the other examples that follow. Because we're looking at the same curve, meaning it has the same mean and the same standard deviation for all 3 examples. So I'm just going to sketch it something that looks like this. And I have my standard deviation value right here, which is good. I know that my mu value specifically is 50, so I can label it. And just for fun, so again we can get the idea of how the normal curve works, we know that we can go up to 3 standard deviations over, and that the area under the curve, 3 standard deviations over to the right and to the left, represents 99.7% of all of the data points. So let's just put those in for fun. If I add 5, I can get 55 here, and then I can get 60 and 65 here. And of course, along the right-hand side here, I have the random variable x. Subtracting 5, I go 45, 40, and 35. Okay, and remember, these keep going on and on because these are asymptotic. I'm just going to highlight 50 by putting in a line of symmetry there just to show that it's the mean. So what this question wants from us is the area under the curve from 45 downward. So from here and less. Okay. What I want to do today is I want to do a recap of our previous lesson. How can we find the area of that curve using z-scores and our table of values, but then I'll show you how we can use it doing Google Sheets too. So as a recap, if we want to find the area of the curve from our table, we got to find the z-score first. So we know that z is equal to x minus mu all divided by standard deviation. I'm going to jump straight to putting in those values. So 45 minus 50, this minus mu, divided by standard deviation, which is 5. So you can see I'm going to get negative 5 on the top, divided by 5 here, means my z-score is going to be negative 1. And if I go to the table to convert that into a probability, I discover that the probability for x being less than or equal to 45 can be read directly off that table. Let's review how to do that. So remember that this table has negative z-scores on the left and positive on the right, and this is the one we're using from your textbook. So if we go to z equals negative 1, we'll go all the way down the left side first, 1.0, and we want to get to the second decimal place. We'll work across until we get to it. So it's exactly 1, so we're going to go to 1.00, and we can see that our probability is 0.1587. So we can answer it directly there. If you wanted to convert it into percent, you could say it's approximately 15.9%. Now, let's compare that to what we would input into Google Sheets. So in Google Sheets, you would pick a cell and you would type in the following programming. You would say norm dists for normal distribution. You would put in the value of x first. X here is 45, comma. Then we would put in the value of the mean, which is 50. Then we would put in the value of the standard deviation, which is 5. And then finally, the programming wants us to put in the word true. And I invite you to try this right now in a cell of Google Sheets so that you know how to do it. When you hit enter, you should end up with, in that cell of the spreadsheet, a value of 0.1587, and there are more decimals as well. I chose to stop there, and lo and behold, that also equals 15.9%. So that's a good thing that both methods give us the same answer. Let's do another scenario. This time, instead of doing an area under the curve to the left, let's do an area under the curve to the right. So I'm going to just simply erase this one so that I can use the same diagram for this scenario. This time we're going to look at the probability for when x is greater than or equal to 54. So I'm going to draw in a line here, approximately at 54, a little bit under, and I want us to realize that this time we're finding the area of the curve here. Okay. Let's review how to do it with z-scores first. So we would find the z-score for 54 and less. So we can do 54 minus the mean, which is 50, divided by the standard deviation, which is 5. Mental math would suggest that I'm going to get 4/5 here. If I convert that into a decimal, I'm going to jump ahead a little bit here, I would get 0.800. Actually, I'll just do 10 because our tables only go to 2 decimal places. So from the table, okay, I can discover what the probability would be for less than that. I'd actually kind of like to go directly to finding the area of this section though. So what I'm going to say here is that the probability of x when it's greater than or equal to 54 is equal to 1 minus, right, the whole curve minus the section I just calculated, or minus the white area, which is the probability when x is less than or equal to 54. So now I'm going to go to the table and I'm going to find out what the z-score of 0.80 corresponds to as a probability. So going here, I'm on the positive side. Here's 0.8 and 0.800 would put me here. Looks like my probability is 0.7881. Little sidebar for a moment. I really encourage you to have some straight edges when you are finding values on this table. It's so easy to slip by going up or down a row if you just eyeball it. Sticky notes work great for this, just as a suggestion. So 0.7881 is what's going to go in here. So the value or the area under the curve for this section is 0.2119. If I wanted to, I could convert it to 21.2%. Now, if you want to put it into Google Sheets, we're going to program it in a similar way. We're going to do 1 minus the normal distribution, and this you would have to type in equals and 1 minus norm dist into the cell of Google Sheets. And we will use the x value, which is 54, the mean, which is 50, the standard deviation, which is 5, and then the word true. And when you hit enter into that cell, and again, I encourage you to try this, you should end up with 0.2119, which is equal to 21.2%. You get the same answer in both cases. So this is pretty slick. It's a little bit faster, I think, than this method, but I do want you to be able to do both. All right, one more example. We did an area under the curve to the left, under the curve to the right. Let's now do a section of the curve. So this time we're going to find the probability of an x value occurring between 42 and 53. So let's make this visual. 42 would be approximately here, and 53 would be approximately here. So we're looking at the area of the curve here. All right, now we are going to have to find two z values, one for the x value of 53 and one for 42. So I'm going to show those both here. So my z value for the lower one, and I'm going to write the word lower just so I can keep track of what I'm doing, would be 42 minus the mean over the standard deviation. This is negative 8 over 5, which comes out to negative 1.60. I'll go to the table in just a moment. Let's also do Z upper for the upper limit of this probability. So let's do 53 minus 50 all over 5. That would be 3/5, which comes out to 0.60. Now I can look these up together. So I'm going to do a therefore the probability for x being less than or equal to 42 is a number, and the probability for x being less than or equal to 53 will have a value as well. I'll put these underneath for space. All right, so negative 1.6. I'm going to go on the negative side. I'll scroll down to 1.6, go across to 1.60. There's my probability. It is 0.548. I'm going to write that down. Let's do the same thing now for positive 0.6. So go over to here, down 0.6. It's 0.60. Our probability is 0.7257. Okay, so the probability will be the difference between these. Okay, so the probability between values 42 and 53 for x would be equal to 0.7257 minus 0.548. There was a 0 in here I think I missed. I did. Let me just go back and correct that. Sorry about that. I was thinking I should have 4 digits. There we go. And when you do that subtraction, you get 0.6709, which if you wanted to write as a percentage would be 67.1%. Okay, so this is using non-electronic means. But if you wanted to use Google Sheets, what you would input into a cell would be the area of the curve for when x is 54 subtracted from the area of the curve when x is 42. So it would look like this. In this cell you would type equals norm dist, and we'll start with the higher value of x. So 53, mu is 50, standard deviation is 5, and we end with the word true. Okay, minus the normal distribution for when x is 42. And the mean is still 50, the standard deviation is still 5, and we write the word true. And again, pause the video if you need to and go type this in to see if you can do it. Okay? When you hit enter or equals, you should end up with a value of, not surprisingly, 0.6709 and some change. And when you round that to a percentage, you would get 67.1%, which is the exact same value as using the z-scores. So this is pretty handy to be able to do, but I also want to show you how it relates to the method you learned about in the previous video. Let's continue with a few more examples. And again, I'm going to focus, even though we're focusing on learning how to use Google Sheets in this lesson, I want to do a comparative between the two methods so that you're fluid and comfortable with both of them. Okay, in example 3, you are told that you have a normal distribution. Sorry, example 4. You have a normal distribution where the mean is 21.7 and the variance is 1.44. And again, one of the first things I like to do is to identify those things. This is the variance, so therefore I'm going to take the square root of it to find the standard deviation. That makes it 1.2. Okay, this time I'm not going to draw a picture, but feel free to in your notes if you wish to. And again, I want to show what's the probability of x being between 20.2, and 22.2. This is a really nice continuous example here because we've got some decimal values we're working with. Okay. First of all, we're going to use the tables. Okay. So in using the tables, again, you're going to have to find some z-scores for each of them. And you would do x minus the mean, all divided by the standard deviation. I'm going to go a little bit ahead here and tell you that that comes out to negative 1.25. So that's for the lower z. The upper z, same thing, 22.2 minus mu, 21.7, all divided by the standard deviation 1.2. It comes out to 0.416 repeater. Okay, so we can, from these, go to the tables and find the probabilities. I'm going to go a little quicker because I think you get the idea, or I hope you get the idea, of how to use the table. And I'm going to go straight to the answers. So the probability then of x in between these two ranges is equal to the probability for the higher one minus the probability for the lower one. Now, fast forwarding, and when I look up the z-score on the table and discover the probability that goes with it, and this is for the lower one, it comes out to 0.1056. Now, what's tricky about this one, actually I'll come back to that in a second. No, sorry, that one's fine. I had to think about that for a sec. Let's go to... Okay, hang on. I'll put these in first and then I actually will go back and show you where I got them because there's a little item to discuss here. So for the lower one right here, okay, if I go to negative 1.25, I can find an exact probability for it. So negative 1.2, and then I'm going to have to go over to 5 or 0.5 right there. Probability is 0.1056. Okay, that corresponded with the lower one, so there it is. Okay, now this one is 0.416 repeater, so 66666. How am I going to find that on my table? Well, I'm going to go down to 0.41 for starters. So that will take me to here. And I know that I'm between 0.41 and between 0.42. Now 0.416 is closer to 0.42 than it is to 0.41. And obviously there's a true value that would go in here for this. I'm going to have to do my best estimation. I'm going to say to myself, is it closer to this value or closer to this value? I'm going to choose 0.42 because it's closer to that one. So my probability comes out to 0.6628. Okay, that one's a little bit approximate. So I'm just going to highlight that for a second because it'll come up in our conversation after we use the Google Sheets one too. Okay, so this one had a little bit of an approximation going on. When I subtract those two values, I get 0.5572 or approximately 55.7%. Okay, now how are we going to use Google Sheets? Well, we're going to do the exact same type of programming. When you go into Google Sheets, you're going to type into your cell equals the normal distribution for the higher value, which was 22.2. The mean is 21.7. Standard deviation is 1.2, and we end with the word true. Okay, we're going to subtract. I'm going to write it down here just so you can see it. The normal distribution for the lower value. So 20.2. We still have the same mean, same standard deviation, word true. Now this time when you hit enter, you will end up with a value of 0.55 0.59. Now when you compare it to the value you had using the tables, they don't come out exact, but the reason for that is because of this approximation you had to do. However, when you round it to the nearest percentage, we get 55.6%, and man, that's pretty close. Okay, so obviously Google Sheets is a little bit more accurate way of doing it if you can't get Z values that fit perfectly on the table.